So, how many points do you really need to graph a line? At a minimum. Well, it's a whole lot less than 5. It's less than 3. You really need only 2 points. And we've talked about it before. And now we're going to learn some techniques, getting some stuff where we only use 2 points to graph a line. Why? Well, because it's fast. We don't really want to graph lines with plotting points. It's slow. We had to use more than 2. We had to use 3 points just to check our work. And sometimes even then it's rough because negatives and all that stuff throw it off. So we're going to be learning about how to graph lines or linear equations with what's called the intercept method. So basically, looking for the 2 things that we found in the last video, the x-intercept and the y-intercept of a line. If you think about a line, that diagonal line, can have only one x-intercept and one y-intercept. It's not going to come back and loop around. It's not going to come up and loop back and get x's again. It's a line. It goes forever in a straight diagonal line. That's what we're talking about. Now, let's look at our examples here. Could you solve that for y? Could you solve it for y and then plug in some numbers and graph the line by plotting points? Of course. Could you solve it for y and graph with a slope and a y-intercept? I've talked about it. I haven't really unpacked that yet, but yeah, you could. Now, do you have to do that? No. In math, we don't give different techniques in math to make things harder for you to remember more crap. You go, what the heck, dude? Why so much stuff? Really, in math, we give different techniques to make your life easier. You see, there's different ways to solve things, different ways to graph things based on different scenarios that you're given. So when we're given something solved for y, we're going to have a technique for that, and it ain't plotting points. When we have something that's solved for standard form, with your x's and y's on one side and your constant on the other, this is going to be your best friend. You're going to love intercept method for stuff that looks like this, for stuff that looks like this. Stuff that's solved for y, not so much. Stuff without a constant, no. And we're going to get to that in the very last example in this video. But for this right here, the intercept method is awesome. Could you plug in points? Yes. Should you? Almost never. Should you solve that for y? No. Not unless you want to find the slope, and we'll talk about that too. What we're going to do in this video is we're basically going to go backwards from this idea. So what we found out last video was that the y-coordinate for every x-intercept ever is 0. You're always getting x, 0 for your x-intercept. What if we went backwards from that? What if we take that knowledge that if the y-coordinate for every x-intercept is 0, let's let the y-coordinate be 0, and it'll give us our x-intercept. It's just working backwards. If the x-coordinate for every y-intercept is 0, let's let the x-coordinate be 0, and it'll give us back our y-intercept. That's what we do with the intercept method, and it's surprisingly easy. It's kind of cool. So let's take a look at this. Solve for y? No, it's even easier than that. Let's use the fact that the x and the y-coordinate are 0 to give us our intercepts, our x and our y-intercepts. So here's how that works. Let's start with the y-coordinate being 0. What's that going to give us? If I let the y be 0, the y height of 0, so the height is 0, it's going to give us some sort of x-intercept. Let's try that. So let's let y equal 0. What's that going to do? What's that going to do to the y variable? Are you still going to have a y variable if you let y equal 0? Is it still even going to be there? What's the only variable that's left? This is kind of nice too. It's an easy way to identify what you're doing and that what you're doing is right. If you let the y equal 0, essentially what it does is it basically removes that entire term. You plug in 0 for y, anything times 0 is 0. It's gone. What's the only variable left? Well, that tells you what intercept you just found. If you let the y equal 0, you eliminate that term. If you let the y equal 0, you're only left with an x, and you're only left with something on the x. That's kind of nice. So when we let y equal 0, this is the intercept method at work, we really just get 2x equals 10. Again, what happened to the 5y? You made it 0. It's gone, completely gone. 5 times 0, 0. Now, if we're only left with something that has x's in it, can you solve it for x? If you can, then here's what you're doing. Think about this just so it makes sense to you, okay? Don't just walk through these steps and kind of get the steps, get the knowledge behind the steps. By calling y 0, you're restricting yourself. Here's y equals 0. You're restricting yourself to somewhere on this line, somewhere on the x-axis. By saying this, you are here. By solving this, you're figuring out where you are on here. So y equals 0 puts you here. Solving for x puts you exactly on the x-axis where you need to be. That is finding the x-intercept. By letting your y-coordinate be 0, you are finding your x-intercept. That's why this is called the intercept method of graphing. Because if you find both of your intercepts, that's 2 points. You really only need 2 points to graph a line with this method. So let's divide. Y'all know how to do this. Let's divide by 2. We get x equals 5. Now you stop right now. I don't care what class you're in. What I want you to do, I want you to write that as a freaking point. Do not tell me that the x-intercept is 5. Please, please don't do that to me. There's a lot of points that have an x-coordinate of 5. We found a specific one. We found a specific point that has a y-coordinate of 0 and an x-coordinate of 5. That's one specific point on the graph, and that is what the x-intercept is. It's a point 5, 0. Get it right. Get it in order. Get it x, y, horizontal, vertical, 5, 0. That means that this line, for sure, has to go through that point. That's the idea. If every x-intercept has a y-coordinate of 0, we just set our y-coordinate equals 0, and it gave us our x-intercept. That's awesome. We only need one more. Now, what do you think we're going to do? If we let y equals 0 to find the x-intercept, what do we need to find the y-intercept? Well, that's what we unpacked last video. Is we looked at that and said, wait a minute, it looks like the x-coordinate for every y-intercept is also 0. So setting the x equal to 0 says, here's my x, let's put it equal to 0. That's going to put us somewhere on this y-axis. By letting the x-coordinate equal 0, you're finding the y-intercept. So if the x-coordinate of every y-intercept is 0, set the x-coordinate equal to 0, and you're going to find your y-intercept. So let's let that x equal 0. Well, what's it do? If I put 0 in for here, let's see, 2 times 0 is 0. Got it. 0 plus 5y. This is telling you something here. You got to keep whatever that sign is. If that's a plus, you make it positive 5y. If that had been a minus, you make it negative 5y. You got to keep track of that. So 2 times 0, that's 0. 0 plus 5y, that's 5y. Essentially, you're just removing the x's. What's the only variable left? The only variable left is y. It's awesome. That tells you what axis you're on right there. If you remove a variable, you're on an axis. If you remove a variable by putting in 0, you're on an axis. Right now we're on the y-axis. So we've covered up x. Some people call it the cover-up method also. So if you plug in the 0 for x, it removes that whole term. Pretend like you covered up. And then you have positive 5. Don't do this. Do this. Positive 5y equals 10. If you solve, y equals 2. Now again, we get a point. And what we notice is that if you let x equals 0, your x-coordinate is 0. It gave you a y-coordinate of 2. That's your y-intercept. It's a point. Don't just tell me it's 2. It's 0, 2. And that's right here. That's a beautiful thing. Because we did all of that with minimal work. We didn't have to solve for y. We didn't have to plug in points. I mean, kind of barely. We plugged in 2 coordinates, and they were easy ones. They were 0. And it gave us 2 points. That's the minimum number of points that you need for graphing, but it's sufficient for graphing a line. That's awesome. So here's what I want you to get out of this. We are going to be learning different techniques for different forms of a linear equation. If you're given something in standard form with your variables on one side and a constant, a non-zero constant on the right-hand side, the intercept method is your best friend. It's going to let you graph by simply covering up and dividing. That's piece of cake. So we have 2 points. Let's graph with the intercept method of a line. show that thing goes on forever, and that's your line. That is the graphical interpretation of that linear equation in two variables. There's only one downside to doing this, and it's not in the graphing part. That's beautiful. Can you see the downside? You see this form of a line. If you had to tell me what I know we haven't really got to slope yet, but and we'd be talking about it. If you had to tell me what the slope is, would you tell me the slope is positive or negative? Look at your line. Is it climbing or falling as we go from left to right? That means we get a negative slope. Does that say anything about having a negative slope? That's the downside to this, is that if you do not solve it for y, there's no way for us to tell the slope without actually counting down 1, 2, that's negative 2, and over 5. 1, 2, 3, 4, 5. So you could find the slope, negative 2/5. That's what the slope of this line is. It's negative, it's falling. It's down 2, it's over 5. That's negative 2/5. That's cool. We'll figure that out in slope. But it's not given to you explicitly in the form. Solving for y would do that. So if you want to do that really quick, if you solve for y, you subtract 2x and you divide by 5, that's negative 2/5 x plus 2. That's what you would get if you solve for y. Now that's cool. You could have done that. You could have graphed it this way. Y-intercept of 2, y-intercept of 2. Down 2 over 5, down 2 to the right 5. It's the same thing, but that's more work. So you kind of have to use these methods predicated on what you want. If you have to give someone the slope, you're going to have to solve for y anyway. If you don't, if you're asked just to graph it really quick, and we use this for linear inequalities and a few, well, graphing linear inequalities in two variables in a few videos here. If all you gotta do is graph it, man, that's so nice. So right now I want to put this together in your head. Different forms have different techniques. If you have to graph, the intercept method is fantastic when it looks like this. Not so fantastic when it looks like this. The slope intercept method would be great for this. So what I'm trying to do here is avoid points altogether. I don't want to plot points. I want to use purposeful methods to graph efficiently. Let's try that with one more. Maybe you can do it now. The one thing I want you to do is watch out for that negative. That can get you. So we're going to start moving a little quicker here. If it's moving too quick, go back and watch that example again. Make sure that you understand the interplay between the zero coordinates and the specific intercepts that they give you. So check it out. First thing I want to look at, is this a good form for intercept method, or is it a good form for the slope method? Well, if your variables are all on one side and your constants on the other side, this is a great time to cover crap up and divide. That's the intercept method. So let's find it. What I want you to do is let x equal 0 and let y equal 0. And it doesn't matter in which order you do this, it does not matter. So if you're going to let x equal 0, I'll do this first this time. Let x equal 0, this whole term is gone. This is what I want to start with. Focus right now, okay? Don't lose this. If you let x equal 0 and you cover this up, basically you're letting the term go to 0 here. X is 0. You're going to be somewhere on the y-axis. Don't do this junk to me. Don't do that. Please don't do that. If you plug in 0 for x, this becomes 0. 0 minus 3y is negative 3y. You always have to keep the sign in front of your term. So you plug in 0 for x, you're going to get negative 3y equals 15. It's not hard, it's just important. Like 95% of all math errors are sign errors, even like through Calculus 3. I mean, I teach a lot of that. And when you get there, students are still doing simple little problems because they're not focused on it. This is the stuff that kills you. This stuff you go home, you get so frustrated, you go, oh, I can't believe I did that. I don't know where that came from, but I hear that a lot. Can't believe I did that. So let's divide this by negative 3. Remember, we're trying to get ones when we're dividing. And we get y equals negative 5. Do you see this? If you kind of muck this up a little bit and forget the negative, your y-intercept is going to be completely backwards, and there's no way for you to tell because we're not checking with another point. You got to be rock solid on this, on getting your signs correct. Because if you don't have that negative, you divide by positive 3 and you get positive 5. It would not be here. It would be here if you get it wrong. So one more thing right as a point. So we know we plugged in 0 for x. That is how we got the y-intercept. We got negative 5 as the y-coordinate of our y-intercept. Hey, that's here. Man, we're halfway done. Now we've just got to let the y-coordinate go to 0. If we do that, we let y equal 0. That's kind of nice. All we're doing is we're putting ourselves somewhere on the x-axis. Let y equal 0. You're somewhere here. And then we're saying if y does equal 0, that whole term disappears. We get positive 5x, we get 15, we divide by 5, and we get 3. Write this as a point. You do now have an x-intercept. The y equals 0 ensured that. We just found the x-coordinate of that x-intercept. Now it's 3, 3, 0. Given your 2 points, you graph that line pretty nicely. Was there any real good way to tell what the slope was from there? Not really. It doesn't tell you whether it goes up or down. It doesn't tell you whether it climbs or falls unless you solve for y. So this method is awesome for accurate, efficient, effective, quick graphing if your variables are on one side. It does not inherently tell you the slope. That's what the slope-intercept form does. That's in a few videos. But it's a wonderful method to avoid plotting points if your variables are on one side. I'm going to put 2 more on the board. I would like you to try them on your own. I'm going to go quickly through them. I'm going to show you the bare bones of it. I'm going to model my thought process to you for sure, but I want to show you how quick this can go. Because in the future, you're not going to have test questions that ask you to do this. Doing this is going to be part of your test questions in the future. Like when we graph linear inequalities in 2 variables, you're just going to have to know how to graph lines quickly and then shade aside and see where the overlap is. That's coming up. So let's try these 2. I'd love for you to try them on your own. Use the intercept method. Look at why the intercept method is going to work, because where our variable's at, the format of our line, the standard form of our line, and then see if you can graph them. Hey, do you think it matters whether I have my x's first or my y's first as far as your math? Normally we love to put our x's first, but if you're dividing, does it really matter? Let's do 1 more. Throw tons of negatives at you there. Give yourself a moment, pause the video if you have to, and try these 2. I want you to notice a few things about them. I want you to notice where the variables are. Are they all on one side or are they solved for y? That's really the 2 categories we get. I want you to notice that the intercept method is going to work fantastic because we have the variables on one side. It doesn't really matter in what order they are. Normally we put our x's first. That would be like typical standard form. But even if they're out of order, who freaking cares? Same thing here. So try it now, and then come back, and I'm gonna get this done quickly. So hopefully you've done it. I'm gonna model my thoughts to you. So I'm looking at these problems. First thing I notice, it's a linear equation. I've got 2 variables. They've each got power 1, and we got an equal sign. Now we're gonna graph them. So I'm tasked with graphing these lines. I know they're diagonal lines. The first thing I'm looking for is the form of the line. If the variables are on one side, that's called standard form. They're out of order here, but it doesn't really matter. Right there, as soon as I see standard form, I'm thinking, I don't even have to solve this for y. All I've got to do is figure out my 2 intercepts. I'm going to let x equal 0 for my y-intercept. I'm going to let y equal 0 for my x-intercept. That's going to give me 2 points, and I plot them. So I'm thinking x equals 0. If x equals 0, then this whole term is essentially gone. We are left with negative 2y equals 18. I'm watching my signs and thinking I don't want to mess up my signs. If we divide by negative 2, then y equals negative 9. And right now in my head I'm thinking if I let x equal 0, I'm on the y-axis. That's why I only have a y variable left. And I write out my point just to be very clear. So I want to make sure that I know I have a y-intercept here. Now that I found my y-intercept, I'm going to find my x-intercept. X-intercepts are found by setting y equals 0. So I'm thinking in my head, okay, I let x equals 0, that's for y. I let y equals 0, that's for x. If I let y equals 0, notice how that's the first term here. That's okay. I just want to make real sure that I'm not covering up any part of the second term. I'm not covering up the sign. So y equals 0 eliminates this term. So we have positive 6x equals 18. No problem. Let's divide by 6. I'm thinking I definitely want to solve for x. I want to be getting dividing so I get the number 1, so I get my x variable back. The right side plays along, I get 3. And hey, I plugged in y equals 0. That's cool. I should only be left with an x value. That's somewhere on the x-axis. That's an x-intercept. Let's write that out. So 0, negative 9, and I got 3, 0. That's 2 points, and we can graph any line with just 2 points using the intercept method. Oh man, I had a big negative 9. Crap. So I'll make my scale pretty small here. Here's 0, negative 9 for our y-intercept, no problem. Then we have 3, 0 for our x-intercept. And when you get good at this, when you don't have to show your work anymore, say you're in calculus or wherever you're going with this class, you can do this very quickly. If you know about intercept method, you can literally do it in your head and go, hey, negative 9 for the y, right there. Positive 3 for the x when you divide, right there. 5 seconds, you get a line. And it's an accurate line. That's what's good about this. That's what's money, is that you're not getting crappy lines. You're getting really quality lines with this technique. It's fantastic. The last one, man, there's negatives flying around everywhere, but we do the same technique, so I'm looking at it. I'm noticing a couple things. I'm noticing my variables are on the left-hand side, and I have a non-zero constant on the right, and I'm asked to graph it. It's going to be a line. It's a linear equation, 2 variables, but I can use the intercept method really nicely. I'm going to let x equals 0 first. It doesn't matter the order in which you do this. So I let x equals 0. Basically, this term is gone. Do not freaking do this. Do this. That negative y has to be what you're left with. Now, that's not good enough. You got to solve for y. So if you remember about coefficients, there's really a little negative 1 up front. Let's divide by negative 1. Negative y divided by negative 1. Divided by 1 gives you back the whatever you divide by. Negative divided by negative is a positive. On the right-hand side, you also get positive 1. What that has done is that has given us a y-intercept. You set x equal to 0, you get something in the y. In this case, we get 0, 1. The 0 we took for granted, that's how we got the y. We get the y of 1. Now we let y equal 0. We let y equal 0, we're going to only be left with an x-coordinate, the x-coordinate of the x-intercept. So y equals 0, basically just covering up. You got negative x equals negative 1. Do the same technique. Divide by negative 1. And x equals 1. So we had 0, 1, and now we have 1, 0. The y equals 0 told you on the x-axis. This just showed you where you are on the x-axis. Yeah, these are much better points. You got 1s. Love that. So let's see. 0, 1, that's about here. 1, 0, that's about here. I know that this, the slope. Is the slope positive or negative? What do you think? What's the line going to do? Is it climbing? Is it falling? Climbing means positive slope. I'm getting you prepped for that for the next few lessons. Falling means negative slope. So we certainly have a negative slope, but it doesn't show you here. Right there, it doesn't show you that. It would only show you that if you solved for y. That's why solving for y is important. Relevant for graphing lines? No, but very relevant for finding slope. So anytime you have to find the slope, solve for y without having to graph it and backtrack and count up and down and left and right and stuff. That's it. That's a really accurate picture of our graph for minimal work. Do you get it? Do you understand right now how to avoid plotting points? If you have the form like this, where your variables on one side, constant on the other, you can graph this in about 5 seconds with intercept method of graphing, also called cover-up method. Let x equals 0 to find the y, let y equals 0 to find the x. That's pretty much it. Just write this stuff as points, not just as individual values like that. Write them as points, and it'll really make it concrete for you. Also, I want to point out that at this time, if you have not watched the How to Study Math stuff, that video, you should really be going back and looking at your earlier material before moving forward. So refresh your memory on plotting points, on doing that stuff, on solving for y. That's really relevant as we move forward, so I want to make sure it's fresh in your head. What I'm going to do now for the last 5 minutes of this video, I'm going to illustrate something. I'm going to illustrate that this method does not always work. So you really need to pay attention to this. Don't zone out right now. Don't just skip through the next section. This is a big deal. So we're going to look at one more. Let's do... Follow me along here. Is it an equation? How many variables you got? Are those variables raised to the first power? So whatever I put over here, listen carefully, whatever I put over here, this is going to be a linear equation in 2 variables. If I put any number over here, it's going to be a linear equation in 2 variables. That means something. That means that you are going to get a diagonal line. 100% sure, because you got 2 variables raised to the first power. We know that those make lines. Check it out. You're going to want me to put a number up there like 30. You're going to love that. Because if I put 30 up there, you're like, done, that's awesome. Because your x-intercept would be 5, 0, and your y-intercept would be 0, negative 6. Done. That'd be so fantastic. Or maybe I said this backwards. X would be 5, so you'd have 5, 0. I think I said that. And then your 0, negative 6 would be your y-intercept. That'd be beautiful. Or if I put 60 up there, or 90, kind of big numbers, but you get the intercepts very easily. There's one number that the intercept method does not work with. That number is 0. Intercept method, yes, unless you put that. Now I want you to think about why. Why doesn't that work? If you let x equals 0, looks like it should work. Let x equals 0, this is gone. 6 times 0 is 0. You'd have negative 5y equals 0. Yeah, you can divide by negative 5, and yes, you can divide 0 by a number. That's fine. You're going to get 0 out of that. If you don't know why that is, I get some videos in pre-algebra that explain when you can and when you can't divide by 0. Well, when you divide with a number 0. 0 divided by a number is 0, for sure. Well, wait a minute. Plugged in 0, I get, oh, crap, that's going to hurt us. Plugged in 0, got out 0. That's 0, 0, no matter how you cut it. Plug in 0 for y. Plug in 0 for y. This whole thing's gone. Divide by 6, and x is 0 again. Oh, wait a minute. It's also 0, 0. Shoot. How many points do you need to graph a line? 2 points. Do we have 2 points? Yeah. But wait a minute. You need 2 different points to graph a line, not the same point twice. That's the problem here. Do you see what I'm talking about? Do you see that if I have 0 here, no matter what you divide by, you are going to get 0. So you're going to get 0, 0 twice. That's a problem, because when you try to graph it, we plot 0, 0, we plot 0, 0 again, and you're not just going to be a 45-degree angle through that. You don't know what you're doing. Are you going to go up? Are you going to go down? What are you going to do? What's your slope? You don't know. That is the problem here. So if you have a constant, awesome. No matter what the constant is, even for fractions, you're fine. But if you have a 0, this method fails. That's what necessitates a third method. Method 1, plotting points. That sucks, we never use it. Method 2, intercept method. Awesome, awesome if your variables are on one side and you have a non-zero constant on the right. Now that phrase, that verbiage should start making sense. Oh, that's why we need not zero. Because if we do have zero, you're going to get the same point twice. Well, hey, at least you know your x and your y-intercept. They're both zero. They're both the origin. It goes through the origin. That means something. If you have a zero over here, variables here, zero over here, you are going through the origin. Now, what's the alternative? The only way to actually do anything with this and figure out what's going on is to solve this for y. We explore that when we talk about slope-intercept. I can show you here if you really want to. If you solve this for y, you'd be subtracting 6x is what most of you are probably going to say. A lot of people would tell me here, subtract 6x. You could have also added 5y to both sides to avoid the next step of dividing by negative. If you do this method, we get positive 6/5 x. Notice the negative divided by negative, okay? You're going to get positive 6/5 x. Oh, whoa. Plus what? Y equals 6/5 x plus, what's over here? Where's your constant? What's your constant in math when you don't have one? Yeah, it's 0. I hope you said 0, otherwise it'd be like, yeah, it's 0. You're like, I didn't even know that. If you don't have a number back there, you're adding 0. You can add 0 to any number, it doesn't change it. So, but that now fits our form. Look at how that fits our form. This says that your y-intercept, you're solved for y now. Your y-intercept is whatever that freaking number is. Your y-intercept is 0, 0. Cover up the x, you get 0. You already knew that. That's exactly why we couldn't use this method, because we went through the origin. You're at 0, 0. Interesting. But because you solve for y, and because I've tried to build this idea of slope in your head, your slope can tell you your next point. Your next point would be, well, what do you think? Are you going up or are you going down? If it's positive for your numerator, you're going up 6 spots. And then you're always going to the right. You always run to the right. Run right. Always run to the right 5 spots. You'd be up 6. And then right 5. And if you miss your point, you did make it bigger. And that gives you a pretty good interpretation of what this line actually does. The big thing to notice here is, works great if you got a number. Don't work so great if you have a number that's 0. The 0 value says you're going to the origin, I proved y, but it won't tell you how. It won't tell you whether you're climbing or falling or how you're climbing or falling. That's why we're going to have a third method in just a little while. So the next couple videos, we're going to talk about some special cases, how to do this with fractions and decimals and some other nasty stuff. We're going to talk about horizontal and vertical lines, and then we're going to start talking about slope. I'm going to show you the slope formula. We'll talk all about slope, everything you need to know about slope, and then we start dealing with that formula exclusively, that form of the line, slope-intercept. I hope this made sense to you. I'll see you next time when we talk about how to do this with some fractions and decimals.